Everyone, we are very happy today to be able to invite Ginny White, Miss Ginny White, to give an online lecture. Ginny, she's working in Holland at this point in time. But let me tell you the title. What the title of her talk is a data engineering and digital transformation in Dutch water management. In fact, she's now working as a data engineer at the digital solution team of a company called Royal HaskoningDHV in Netherlands, which is a very big country. Which is a very big company. And if you're interested, you could go Google it. And Ginny is working there as a data engineer. And recently, when she told me that what she has been doing, I find it very interesting, and I would say very stimulating. So I decided that we must, invite her to give a talk. So then she'll tell us about what she's doing. She has been teaching as a lecturer on the data science and engineering expert program for the Dutch Water Board. I think that this information would be very useful for many of us. And Ginny, she's from Taiwan. She got her bachelor degree in atmospheric science from the National Taiwan University. And subsequently, she got a fellowship, a scholarship from the Delta Electronic Education Foundation to go to Holland to receive a Master of Science degree in environmental science from the Wageningen University. And she later on she went to Arizona, and she got her master degree in science on computer science from Arizona State University. So she's well trained in many different fields. And then let's now give the time to Ginny. Ginny, please. Thank you so much.
Thank you very much. And today I'm going to talk about some hands-on information from the how Dutch people manage their water, and some real projects here. The Dutch government's trying to do apply data transformation in water management. So this is about the data engineering and digital transformation in Dutch water management. As introduced by Professor Ip, I'm working as a data engineer here. So I work at a company called Royal Haskoning, and what we do is like this is a company with 140 years history, and we work in different sectors like water and maritime. And today I will focus on this area. And we also work in infrastructure and mobility, such as building highway or trying to set up the station, the charging station of electronic cars, or the how to build green buildings, and aviation. Royal Haskoning also have been to Taiwan to help the sustainability transformation in the Taoyuan National Airport. But myself is from the digitalization department, where we do a lot of work in Azure, Microsoft Azure, which is a cloud computing platform, or it's everything about storaging data and computing data, deploying machine learning or deep learning models online on the cloud. And usually I work in water projects. So I got a lot of chances to be assigned to work with the local governments. And here are some projects the company has done before related to water. Like you can see here, there are something about managing floods in different countries. We especially focusing on some Asian countries and African countries because their people still have a lot of work to do to manage the floods and estimate the risk. And also we work on wastewater treatments a lot. For example, the water treatment plants in Kaohsiung, Taiwan is also one of our clients. Also, the coastal changes is getting more and more important in these years because of the climate change. So we see the sand in coastal change the form every year. That is important to sometimes to predict the change of this sand or the shape of a coast, because it can influence, for example, people's life, like the residents living there. They may have to move because of the coastal change, or influence some facilities from companies, like in some European companies, European countries, they have a lot of pipelines around the coast. So this is important to know how the coast will be like maybe 2 or 10 years ago, later. And then in this kind of projects, we apply the quite a new popular technologies called digital twins, which I will introduce to you a bit more later in real projects. But in a nutshell, the digital twins are kind of modeling combining with real-time data. So we have a bit like IoT sensors, for example, can measure temperature or measure the water levels or other things, or like in a factory can be measuring the flaws in pipes. And then we put this real-time data into a model. The model can then predict the results of like what is the current parameters, what is the current data, and then what will the system be like maybe 5 days later. This is so we can according to this results of forecasting, then we can try to change the parameters or try to make some try to think about solution to face the later results. Or if this is like this environment is controllable, like it's in the factory, then we can also think about how to optimize the usage of, for example, energy, or try to do not produce too much products by controlling the speed of machine. Okay, then this is the next page. I'm going to tell you a bit more background about why water management is interesting in the Netherlands. As you know, the Netherlands, the name of Netherlands means the lowland in Dutch. So here you can see the map. In the 1,300 years, the Netherlands is much smaller than what it is now. So basically, 17% of the current Netherlands land is reclaimed from the sea. As you can see, especially here, can you see my cursor? Sorry, full screen. Yeah, here it's called a Zeeland. It's where then later Dutch people went to New Zealand, and they call it New Zealand. It's because here it's called a Zeeland, and actually it means a land on the water, under the sea. So, and this part was 100 years ago, there are also some people living in this part, but they suffered all the time from floods. So later, Dutch people built some dams here, and this is a story I'm going to tell on the next page. Also here you can see there was nothing here in this area, but in 2000, in current Netherlands map, there are new lands, and these are actually all artificial built by Dutch people. And here you can see, here is I think one of the longest dam on the earth is called the Breizam Dike. Dike means dam, and you can actually drive on this with a lot of car lanes, car paths. You can drive from here to there and see both sides are just water. And here you can see something called polders, and this is a very important concept in the Netherlands. Polders means a land which is surrounded by dikes. Dikes is also English, no, dams. So you have a lot of dams, and inside the dams you can control the water level artificially. You can use pumps to pump in, pump out the water. And here you can see some people in the Netherlands are trying to remove the water and build new lands in the polder. So outside here, there are already some dams built, and so they can block the water in this area, and they are pumping out, or they are digging the soil, or they move soil and the rocks from other regions and to make this polder land higher. So then later it can become the agricultural land or even a new city, new village. And here, oh, sorry, go back. Here, this is a place called Urk. This is an example of a village which didn't exist in the past, and this is built on the new land, which was sea and then polder, and then now it's a village. Yes, and also the total land the Netherlands has reclaimed from the ocean is about 1,600 kilometers square. It's quite a lot, like 70% of the country. Sorry, this is not. I think this is the area in last century. So actually there were much more, because the area of the Netherlands is like 40-something thousand square kilometer. So much more, like here. And the next slide, I'm going to tell you about the floods here. As you see in this map, in the Netherlands, they are like 21% of the land is actually lower than the sea level, and more of 60% of the population lives in the areas which is only 0 to 7 meter sea level. So that's really dangerous, consider of global warming and the sea level rising. So like this area, if the dark blue, if there is no dike, then this area is immediately just going to be underwater. And there are a lot of dikes here and there, especially here in the Zeeland, because there was a heavily flooded before. And in total, there are 22,000 miles of dams in the Netherlands. Also, yeah, one very important event which has changed the water management strategy in the Netherlands is the disaster in 20th century. It actually happened in 1953 in Zeeland here. And what happened was like there was a huge storm and caused a surge, and the surge just flooded most of the land here, and lots of people lost their home, and they moved to here in the north, this part, and the government also built more land because of this flood. Nobody can live here at that time, so they need more like refugees places. So they build more land here in the north, and also they thought about how to improve the flood management, and so they came up with a plan called the Delta Works, which is quite famous in this kind of dams building area. So here are a lot of small dams to control the water levels in this area. And after that, now it's much less floodings. Maybe occasionally, like I can hear about it maybe once or twice in the year somewhere in the Netherlands had floods, but never a serious flood anymore nowadays. Also, where is it? Yeah, okay. I think that's all about the flood. So lots of other countries, because of the global warming this year, they're trying to learn from the Netherlands because they are good at keeping water out. And before we notice there's global warming, they're already doing this for hundreds of years. So because of their water management history, so 700 years ago, they already started a government organization, and it's called Waterschappen, but we say water boards, 水利局 in the Netherlands. They were initially hundreds of them. So it's very in every region you have a special water system, like around this river or around that ponds, and they have institutes to manage these water. Then currently the numbers of water boards have been reduced. So it's only 21 Waterschappen now. Then you can see the list here. This is quite interesting because unlike most of the countries, usually the water managing government is under the local governments, like under province or province, sorry, under province or under municipalities or but in the Netherlands, they are totally parallel. They are independent from the other system of governments. So, for example, here, this part like a bit 8, 14, and 2, and a little bit of 18. This should be called the North Holland province, but actually it's separated into 4 or a bit in the middle of 14, cut into different parts because of the nature of the water. Like they consider the water here is more like a system, so therefore that should be one area. And we have different taxing system for water as well, because this is very important for everyone living in the Netherlands. We need extra budget to control the flood, to control the dams, and to do the water treatment, because sometimes we really got lack of water, and we need to, for example, purify the seawater for the agricultural use or drinking water. It could be one of the, drinking water is also important, and also wastewater because of the dry season and the flooding season, and you have different water levels. So also you need to monitor the amount the wastewater treatment plants can handle. So how to distribute this and control the flow to make them more stable is also important and needs a lot of money. So because of the taxing system is independent, we also get election of water boards. I think, last month we just voted for it. They have different parties for water sports. So you need to choose which party is in your favor. They all have different opinion. Like some parties, they focusing on using water for farmers. Some focusing on how to reserve the nature and environments in water area. So it's very interesting to see their opinion and vote for them. Okay, then now we come to the last part of this slide. Is the main tasks of the Waterschap in the Netherlands. They will manage the water level, and also they have to maintain a dike and construction the dike. Sometimes they got broken and we need to rebuild them, and they have to be planned in advance. Otherwise, it's very dangerous for other people here. And water quality is also important. That includes could be ecological quality. For example, the species living in a certain water body, or can be a certain kind of chemical, and they're monitoring this quite frequently. For chemicals, I think it's we have several measurements per month, and for fish, or other animals, we have like per 5 years, and they measure. It's a big survey that will catch fishes and counts the animals in all the water bodies, including just like a canal or a small lake in the area. And also the natural environment in the Netherlands, there are many places is protected by the government, so you cannot go fishing, you cannot go build any houses, you should keep it natural. And like, for example, here, the Waterschap 8, around this coast, there are some artificial island. Dutch people build, put rocks and sand in the sea and then becomes an island. But this is actually for protecting birds. So people cannot go there to build anything, and we can just go bird watching or just keep a distance from them. And the last one is water infrastructure, and this is quite complex. Can be anything, for example, the industry water pipes, or can be we call it slots. It's more like a controlling station of water in the rivers, but the rivers can be also quite small, and they control the flow, can control the water level, and this kind of infrastructure is actually everywhere. If you walk in the Dutch city and along the river, and soon you will see some of them. Okay, and this is the overview of Dutch water boards. And now, yeah, this is just some visualization of like this is what I mean, like a polder and around the riverside. Here are some dikes in the background, I think. Yeah, this picture is not very clear, but this is the flooding area. So it's actually designed for floods. The rivers must flood as a nature. And so we need to keep some space for the flood and do not live here. So sometimes when it's not flooding, there are a lot of this kind of areas for like free range agriculture. I mean, like having cows and sheep there grazing, and when it's flooded and there's nothing, just put the animal back and let the area flood. Also here, this is voting, and here this is this person who is in this video by NOS. He's introducing how the Waterschap can negotiate with farmers because of the water level, and adjust how they do the agriculture. So for example, if it's now we are at the dry season, then maybe you should not plant a certain plant too much, because it can cost us a lot of water. And here is what I mentioned last slide. This is a kind of water infrastructure, and this one is for blocking some water in the river, kind of river, and purifying the water and deal with actually this is a kind of health wastewater plants. Oh, and one thing here, maybe interesting to know, is like this kind of place, as I mentioned, called polder. It's actually very important words in Dutch language as well. That means polderen. This word means it's a verb that means to negotiate and to compromise and to like different stakeholders that discuss something and having some trade-offs, and they finally reach a consensus, and this process called polderen. Just because in Dutch people mind, this is like having some area has flexibilities and can adjust and make everybody happy. Okay, then I go to the next slide. So from here, we get into the next topic, which is called digitalization. Maybe some of you has heard about it, but the overview here I want to mention is different stages of or different degrees of digitalization. So actually we have the first one is called the digitization is actually just like in old time, and people write everything maybe on just their notebooks, or they go measuring water and they say, oh, today the water level is like 3 meters, and just write it on their books. And So in this first stage is to make all the data into digital. So for example, here like we have lectures or some ID cards, like also in Taiwan, it was more like a handwriting for the healthcare things. And now there are a lot of things in getting to the cloud. And so different hospital can search for the history of a patient. And this kind of thing is the first thing we need to do, make things available in the digital form. And then we will go to the second stage, and this is called the digitalization. And in these stages, we talk about automations of some process, and also to string the data or the process, which means like, for example, in the past, maybe you receive an email, then you need to read everything and think a lot and reply to it. Of course, now we can still do it, but what if you got like a 3,000 this kind of emails every day? And then we can do automation for this. Then this is called, there are some tools online or in different kind of cloud platforms that can categorize these emails for you and can make it into like, oh, this one needs your reply, your brain, you need to think as a human, and others like maybe you have some auto reply already designed contents, and they can just send this back to the person who sent you email. And or like someone is monitoring producing pipe, like maybe it's a brewery making beer, a factory, and maybe the some material is getting low. Then when the machine, when the cloud computing center, it can read this data and found, oh, for example, the temperature is weird, or some material is running out, then it will automatically send you a warning. So you don't need a human to watch this data every hour anymore. So that is the second stage of digitalization. We'll automate things and we'll stream the data and make decision or warn the real people in time. And then we go to the last stage, maybe not last because the technology is still evolving, but the third stage we call digital transformation. So this is more than just having data online in computer or just react things like automatically. On this level, it's involving decision making. So just the computer or the computer based on the data can tell you some facts. And however, based on these things, then the people think about some new solution or how to change their strategy. And for example, let me think, what is a good example? Okay, for example, currently, I think EU is going to release a new law. So we are going to make asking colleagues' salary in the workplace legal. So that means previously this is a sensitive topic, you should not ask. But I think they have some data in the system, and they see like the gender gap still exists quite a lot in the European country. Like if you're a female or male, then you're working as the same position, but maybe your salary is still like I don't know, 15% or so difference. Then they see this kind of phenomenon in the database, and also they want to make some change. They want to transform the thing. So maybe they found something like, if people knows each other's salary, then they will try to negotiate more, or it can put more pressure on the HR in the companies to make this salary gap smaller. So this is about a strategy. So they observed the data and they found some phenomenon, and they try to make a new strategy or employ new law to improve the current situation. And this slide is from some third party, and just stole it to explain things. But if you want to know more, you can go to the EDUCAUSE. They have a much more description about transformation there. Okay. Then the next slides, I will briefly talk about. What's the difference between the three roles, because many people heard about, okay, you are data analysis or analyst or data scientists, data engineers. Actually, they're different things. So briefly, I think data analysis is making more things with the business decision. They try to improve the business, so they are more focusing on communication and visualize the data and show like managers or show the clients what should we do. And for data scientists is maybe very fancy, because people think about advanced algorithms or inventing new things, and like ChatGPT, and yeah, it's very strong in math and analyzing data, making new models, machine learning, deep learning models. But yeah, don't look at the salary. I don't think that's correct here. Is this a bit different in Europe? I don't know. This one probably in the USA. And data engineer is something different and could be neglected sometimes. But actually, according to my machine learning engineering colleagues, there was some paper from last year, and actually in current world, when you talk about the data models or in the data industry, is only less than 10% of work is in the data scientists, because they think about the models only. But how to deploy the models, where to deploy, and how efficient it could be, and dealing with data, and to validate the data, and all of this work preparing for a machine learning model or all kind of data model to help their works. And this is a data engineer's job. They need to be very familiar with all kind of cloud facilities, and put the models from data scientists somewhere, and trigger the model, and store the results, or provide the right data to this model. And okay, very brief. And here, we're going to talk about some typical work of data engineers in the company. So sometimes we get a lot of clients with huge Excel sheets, like several GB, and with heavy calculation inside, and client complains sometimes the Excel just crashed. So this is really not good. And from that, we can provide some solution with here. Like this is an example from Azure, so we can use some CSV templates if the client really like Excel, but then store them into some databases. For example, this is a database called SQL, and that means it's a kind of a relational database, so it's more like a table. Sometimes the data cannot be stored in the table. For example, videos cannot be stored in the table. Voices, records cannot be stored in the table. But this kind of Excel things, of course, they are tables, so we can put them in the SQL database, which is very popular. And we need to think about how to secure the data, because sometimes the data are very sensitive. For example, some company, they may provide the data of some volunteers, some volunteers to drive their car around the city and provide their GPS. And sometimes it's with their name even, or emails. These are all sensitive, so we should do some credential setting, or try to remove the important parts, like the name will replace the name with some unique ID, or try to set up the IP or other things to prevent other irrelevant people from accessing this data. And this is a very common example and here, this is another one. This is combining the work with data scientists as well. So there are a lot of documents, sometimes in paper or in Excel as well. And they got digitalized and put into some database again. And here in the cloud, they deploy some models and probably built by data scientists. For example, they have a historical data of how many species are in here and what is the relations, what is the relevance parameters of the amount of these species, and they will make the prediction. So we apply these things and the results of the model and the real data, and we make some visualization dashboards. And this sometimes is real time. So, this one is not, because this is about counting the fishes in water. But sometimes, like, we have other dashboards, like real time water level changings or predicting the flows, and those are just, if you refresh the dashboard, then it should change like every 5 minutes or even 1 minute. And so this is another typical work. Gets data from different sources and putting some computation and storage in between, and the result is the dashboard. Okay. Then here I briefly talk about the challenges in the digitalization. First, because these water boards have a long history, so there are actually a lot of data, but it's everywhere. Can be like APIs. APIs means it's like a system where you can export data, and like I want to know in the address somewhere, and what is the area of that house, and if you get access to this kind of APIs in the Netherlands, they will retrieve the data from a database. Then you can get the answer. It's always in Texas, so it's a very, I would say, software nerdy kind of form. And besides that, it can be from just paper documents or even handwriting. That is really bad, but fortunately, we now can also recognize handwriting to some degree. So we still need some check, but it already accelerated this process. And also, we need to check the version control, because sometimes people just send big Excel files by email. If I change something, but my colleagues also change something, then we get 2 different versions of this Excel files. It's not good. So we need to also check all of these things with the clients, like how can they, what kind of editing way they want. Then we will design this platform for them so they can do the work as usual, and how to validate the data. Okay. Then also some daytime problems happens here in the Netherlands, because in the water boards, for some reason, part of data comes from the 8 a.m. in one day to next day at 8 a.m. And this data between these 24 hours from 8 to 8 is summarized together. And but some other data has come from like a 0 a.m. to the next day at 0 a.m. So in this case, it's really hard if you are, for example, you're managing the work of a water pump, and some wastewater flowing to this area is like a count from 8 to 8. However, some rain data, like how much rain is in this area, then this is from 0 to 0, and this is really hard to deal with then. But fortunately, we have some other models, or we need to negotiate with some stakeholders. Can they provide some raw data? It's actually like what I mentioned in the third point, only aggregation data. So, or sometimes the the meter, the sensors got wrong. So we also need to fill out something like doesn't make sense, so we cannot use this data. Also, the software management is is in the government, so sometimes it could be challenging because for safety reason, for security reason, they need to control the versions of software is available. So not all the advanced tools we can apply in this environment, in their environment. So sometimes we need to think about alternatives and make it work still good enough. And here, I talk about a deep program then. A deep program is actually data science and engineering expert program. This is started from 2021, the first year, and it's a whole year program. They have 2 cohorts, and one is for data science and another one's for data engineers. And all the students are from the Dutch government, water governments especially. So here you can see there are 10 topics for data science, 10 topics for data engineering. It's quite intense because every time you have a block, it's like a 2 weeks trainings, and with I think 2 to 3 day lectures for the students, and they need to do some assignments, and 2 weeks later, 2 to 3 weeks later from the lecture, they need to hand in this assignment, and very intense. So it lasts the whole year. Here it's like some people graduated from this program in 2021, and they are, I can recognize some people, by the way, because they're from the water government. So maybe originally they were managers, they were scientists, maybe they are like plants experts, they know about the plants around the water, and they have this will, they want to learn more about data, either data science or data engineers. And the Waters Hub has this budget, they'll send them to the training, and it's actually quite effective because sometimes I go, before I knew the deep, because it's before I joined this company, and I already, before I knew there's a program deep, I already heard people talk about this in Waters Hub, because those people, after the training, they changed their job. They start to get involved into the digitalization or digital transformation event in the government. Like, for example, last year, I heard in the Waters Hub in Delft, the one graduates people from this program, and he started to predict some water gates, when should they open, by using some data models there. So it's actually improving it a lot, like than just calculation by human before. So it's really happy to see these changes and with technology. This year we got a lot of students, so like 30 and 50 into cohorts. Would be a lot of work. And here, I think we can just go here quite fast because we're running out of time. But I think the benefits is basically real-time monitoring and control. Before digitalization, this is really difficult. Maybe you can have a sensor, but it's not like an IoT or something. Is immediately you can stream the data to some dashboard and make decision. And also modeling, just like I mentioned, you can model and forecast and make some think about solution in advance. Also assets management, like by this we can save some money, and sometimes in other public assets group we need to think about like, oh, this, for example, this lamp around the river, you need to replace it between 3 to 7 years. Then, well, if you just send one person to there to replace only this lamp, it's quite costly. So how to combine the whole environment with the similar facility around, and which are all in the, between their years suggested to be repaired. And this is a big question. And this is one of the example here. Here, I'm going to show you 3 examples quickly about real projects in digitalization and Dutch water management. And the first one is actually it's not in the Netherlands. I found it's in the UK, but not so far. It's called a resilience tool to the coastal change. So it's just like I mentioned earlier about the sand changing. And if you're interested, you can read more texts here. But basically, the end product is something like this. I cannot show you bigger because it should be not so open. This is a secret software, and like this is a course in the UK somewhere. And this is the potential change of the sand shapes. And you can see, you can adjust parameter like to see like maybe half a year later how it will look like. And people can make decisions based on this change and some other data in numbers. And here, another project is water ecology monitoring. Just like here, you see how Dutch people manage their waters really in details. This is not so big area, but all the water, actually the shape is simplified. Otherwise, they have really exact data of how big this water is look like. And for each water body, they have a lot of different parameters. I think hundreds of them. And they're given a score, like it's good or it's bad or somewhere in between. So they were focusing on like, for example, this area is really bad, and they will think about how to improve the quality of this item. Then here they also have some warning. It's also similar to this map, but it's in the table, so maybe clear for number. And the last example here is forecasting the wastewater, and this is some architecture of the things they're using. I block out some data here just so you only see the names of tools, but you can imagine, let me guide you through this. So you can imagine some documents from here, files like in a loose file or in some databases from other governments, or APIs. Again, is like a gate, a data gate. You can retrieve data by asking something. And then everything they store into their water scope, their water boards, data lake. Just think about this as like a big closet, and you can put all the documents inside organizedly in the organized way. And then you can use this called the Azure Synapse. It's actually a cloud computing tool, and they can do a lot of data validation, data preparation, data transform, and into the form they want to use in their model. And then when the data got ready, we got the results, and we show it like into this way. First way is this another cluster, and this is public, everyone can see, or it's in this another thing. This is only for internal use, only the government's officials in this institute can see. And they have different way of securities. Also here, yeah, this is not very important. Anyway, these are all different kind of securities way. So yeah, this is really important, especially when you're a government, you got a lot of people's data. With water is less secured, but sometimes it involving like how much water you use in this home also. So it's very important to keep an eye always on the security. Okay, I hope this information is somewhat in some way could be useful for you. And I think this is maybe the last slide, right? Yes, it is. Sorry, it's a bit long, but that's all. Thank you.
Yeah, thank you so much, Ginny. I think it's a very nice talk.
Thank you.
I think I asked you a couple of questions. Can you see the chat box first? And then there's another question.
Please, yes, I will. Can be run by AI in the future. Oh, yeah, the first question. Yes, I think it's already partly running by AI, but for the strategy decision making level, it could be still some room to be improved. Like, for example, everyone, I don't know, maybe lots of you have been using ChatGPT. and you can find this is current AI can amazingly answer a lot of questions, but sometimes it still make mistakes and is biased based on the data is trained. So I think the question here is more like, yes, now it can be run by AI. I think the technology is there, but how can we make sure it's safe? Or how do we make regulation on this? And this is still heavily under discussed here in Europe. Like to what degree can we trust AI, and who is going to check if the AI is correct and the right way? Did I answer this question?
Yeah, Ginny, very well. Yeah.
Thank you. And do you think the deep program is also needed in Taiwan? That's a really nice aspect. I think that would be great to do this, because I study in Taiwan for my bachelor degree. I studied atmospheric science, the 大气系 in National Taiwan University, and a lot of my friends from the departments are currently working in the Central Weather Bureau in Taiwan, 那个气象局. And they found a lot of databases are still storing in, for example, Excels and some other things. And it would be nice if more people in Taiwan, especially in the government, can get involved in digital transformation. And I think we're already doing it in some aspects, but still, for example, last year or 2 years ago, we got application on the COVID-19 issues, but maybe it can be more, like can be also water, agriculture management, or weather things can be more digitalized. Did I answer this question?
Yeah, but do you have to come back? Yeah, Ginny?
Yeah, come back?
Yeah, to help us.
Yeah, if I can in some way, I'm very willing to share a lot of experience here or so. Yeah.
I mean, there's another question, yeah.
It says something else. I will echo to Professor Yip's question. Oh, the AI chat GPT. Yeah. So she's not here, but if she or he, sorry, then yeah. So in what way should I answer this question? Like, should I type or just say something?
You just say that, yes.
Okay. So yeah, I think this is really interesting, ChatGPT, because I work as an engineer in IT, and I observe my colleagues. A lot of them are actually already applying ChatGPT, but we need to be careful, because the current ChatGPT, if you use it, you're agreed to allow them to use your data. So I think we should think about the data security again. So if you want the AI to help you analyze data, then it should be in your private environment, but not like just free ChatGPT. And I think this will soon be in the market, because I work with Azure. It's a Microsoft data platform, and I think Microsoft currently holds like half of the shares from OpenAI. OpenAI is the company which produced ChatGPT. So what I know is Microsoft is currently working on like how to use this ChatGPT technology into their Azure cloud computation as well. So if that happens, it could be much better to secure our data. And also, who is going to verify this thing is correct? Because as in my experience, and also my colleagues, we sometimes found that ChatGPT can just want to answer you something. It just want to answer you, generate something. So sometimes it's very creative, can give you some something doesn't exist, just make out from nowhere, and because it's designed to be fluent in talking, so it doesn't matter like what it's saying is correct. That's what we need to be aware. I think.
Okay, Ginny, I tell you, this is Professor Wang Xiaowen
Oh,
from
yeah,
成功大学. I will
yeah.
bring her, I will write to her and connect you too, so you could answer her more in case it's necessary. All right.
Okay, sure. That would be nice. Thank you. Deep training program details. Is the training program have any founding support? Yes, this is funded by Dutch government. So it's also like the governments want to get further in digital transformation. So I think so. And yeah, thank you, Jenny. Yeah.
Okay, I mean that I think the Professor Das was asking, maybe he meant that whether there's any possibility of funding support for people to attend the deep program.
Oh, yeah. For other people, I think now it's currently in the Netherlands because we use Dutch in the whole training.
Right. So you have to speak Dutch, right?
Yeah. But I think it's possible to, companies like to make money. So if there are some funding, of course they will send people that speak English and train them in English. It's possible. Yeah, but I don't know where to get fundings. Maybe she proposed something to the organization or proposed to the government like, oh, we really need this change. We want to get more knowledge in data. I don't know how to make it happen in details, but
okay, all right. So I think that the it's 4 o'clock, and Ginny, thank you so much. It's been an hour.
thank you.
It must be 9 o'clock, right, in the morning?
Yeah, now it's 10 o'clock in the
10 o'clock.
Netherlands.
Yeah. So
Yeah.
thank you again. I think it's a very nice talk. Tell you.
Thank you.
I think it's one of the curious and nicest talk we have had in this series. And all right, I'm telling you that your company will be proud of you. Yeah.
Okay, thank you.
All right, Ginny. See you next
All right.
time. Yeah, keep in touch.
Okay.
Yeah.
See
Okay,
you.
bye-bye.
Bye.
I thank you everybody for attending. Yeah. Bye-bye.